In this video, Soundly and Numbynumb NB are going to show that as the camera moves along the towers, the bird doesn't seem to change orientation, and they claim that is proof that this is Soundly has created a fraud. But let's have a listen to what they say.
Freeze on this one, right? So that we're looking at how this bird is positioned when it initially appears in the frame, right? And then so what I'm going to say is that I think that this bird is a two-dimensional image, and that they've used this technology that I'll show a video about, where you can kind of create the illusion of 3 dimensions from a 2-dimensional image. Because like what you'll notice is that as this thing the camera moves so that the perspective on these power lines changes, that the bird doesn't move at all and stays in the exact same orientation. So if I put this down to
so basically, Soundly can't perspective, Soundly can't scale, and Soundly can't.
This? Look.
Yeah, but the bird's on that. To be fair,
no, but look, now it's identical. The orientation after that much motion.
Fucking hell!
Is the exact.
Are you saying that it looks like he's used that photo and based this image on that photo?
I don't know. I know. I think that this bird is added to the photo because that's not in the photo. Like I say, I think it's this kind of complex combination of the elements. Like that's what's.
I agree. How fucking. How
look?
How ridiculous is this?
But you see that illusion, like where you won't notice it unless you look very carefully. Like, see that? Like it looks like you're turning around this thing, but at the very end of all that, this thing is exactly positioned the same.
I agree. I mean, there's ballers in chat that are calling this ridiculous. But how can anybody challenge this on the grounds of ridiculousn's when it happens to be the same fucking bird in the same orientation, as if that's going to be chance? It's ridiculous. Soundly, I'm going to call you out as an absolute fraud. This is the evidence that somebody needed to come across and put together, and this guy is an absolute gem. I mean, look at that. It looks CGI because of the level of focus that's on all the.
Yeah, but this orientation of this bird. They're turning around the bird and the nest, but look.
But the bird's not changing its orientation.
It's a flat image. See that? Because then at the end, you compare the two.
So Hillel Finder says, why the fuck would he add a bird? Why isn't the bird doing what it should be doing, Hillel? That's the question you want to be asking.
You don't see it. Like, I don't have to answer.
All right, so we've heard enough of what they had to say. So the bird seems that it doesn't change orientation. The thing is, we can actually work out how much of a change in angle we are relative to the bird. So we can actually work out, using the clips, to work out exactly the change in angle relative to the bird. So let's do this. All right, so at 16, you can see we went past the post. At 19 seconds, we can see the bird. And see the bird at 22. This video is going at half the speed, 24 to 25. So that the most we can see is from 19 to 25. So what we're going to do is analyze the footage from 19 seconds and 25 seconds and see if we can figure out exactly where the car is on the highway at those 2 moments. So this is at 19 seconds in the clip where we can first start seeing the bird. So here's the bird. What we want to do is try to figure out exactly where the car was when this clip was taken. And we can do this by triangulating lines of sight. So one thing we can do is we can see is that we can count the amount of base of these towers we can count. So let's see, we can count 1, 2, 3, 4, 5, 6, 7. We can count a lot more than 7, but at least 7 bases. And I'm not sure if this is a 7th one, or it could be even a later one, because not sure if that's the first one, the base of the first tower, or the second tower, or third tower, but it doesn't matter. At least the 7th tower can be seen through the first tower. So what I'm doing is I'm calling this tower the square tower because it's the square tower. This is the first of the normal or the regular towers. And we can see that the base of the 7th tower goes through the first tower. So what we can do is we can draw a line of sight from the base of the 7th tower through the base of the first tower, and it also has to go through the base of this square tower, and we'll know, and then we line that out to the road where the car is, and that's where the car would have to be when this was taken. All right, so we're in Google Earth, and this line over here is a line of all the towers. So let me just zoom in and see here are the towers. This tower number 7, tower number 4, tower number 1, square tower, and this is where the car was when it was taking this video. So we'll turn off this line here, and just going to deal with the first tower, second tower, third tower, fourth tower, and 7th tower, and square tower. So let's zoom in so we can identify all the objects. So this is what I call the square tower. All right, it's got a square. It's not the same as the next couple of towers. It's a bit different. Here's the first regular tower. All right, tower number 1. All right, tower number 2, tower number 3, tower number 4, tower number 5, tower number 6, tower number 7. All right, and what did we say? We're going to draw a line from the base of the tower to, so what we have to do is establish what is the base. Now, these two things are the base. It's a bit hard to orientate yourself. Once you understand that there's a shadow, right? That shadow, that is the top of the, that's the shadow of the top of the tower. That's the shadow of the bottom of the tower. So these two things are the base, right? And what we have to do is draw a line from the base of this 7th tower, the left of the base. So that's what I'm doing, this green line from the base. And it has to go through the base of the first tower. Now here's the base of the first tower, and I've actually drawn it a bit to the right of the base of the first tower in order to be more generous. So if I was more accurate, I would have to do it through the base of the first tower, but I've drawn it to the right to be a bit more generous. Plus it has to go through the square tower, which it does. It goes through the square tower. Here's the base of the square tower. And then continue that line out to the road. All right, that's where I would say the most right, the most to the east, the car was at 19 seconds. So where the car was at 19 seconds was probably around here, but I'm going to be a bit more generous and put it over here. Now, in order to figure out where the car was at 25 seconds, we can do something similar. What we can see is that all the bases of all the towers are coming through this, has a line of sight through this square tower. So this tower with the nest on, I'm calling the square tower. The bases of all the towers come through. So we're going to just use the 7th tower because it's definitely in the photo. We have to draw a line of sight from the 7th tower through the left of this square tower. So it has to be within the left of the square tower. And then we can figure out where the car was at this moment. Now let's try to figure out where the car was at 25 seconds in the clip. So as we saw in the clip, at 25 seconds, the base of all the towers, the left base of all the towers went through the square tower. So what I've done is I've drawn a line This time the red line from the base of the 7th tower, but I can use any tower, and it has to go through the red, through the square tower. Right? This time I've put it more to the left of the square tower to be a bit more generous. But really, this red line should come through the tower so to be more accurate. But because I want to be more generous, I'm putting it to the left of the tower. So basically, these lines are the maximum extremes of where the car was at the time of 19 seconds and 25 seconds. All right, so let's go back to where the car is. Now the length, the amount the car traveled maximum in those 6 seconds from 19 seconds in the clip to 25 seconds in the clip is this amount. We can measure that amount, so I've already measured that. Properties, measurement, 17.3 meters. So it's under 18 meters. Okay. Now what we need to do now is measure the angle, the change of the bird, relative to these 2 points. So what we need to do is measure that change in angle. So the bird was on the tower, and the bird was somewhere to the left of the tower. So let's measure that. Take a measuring tool from the left, somewhere in the tower, around there, to this point here, to the most right point it could be. And we can just take down the degrees. All right, and if you look at the amount, the heading degrees, I want you to look at this number over here, degrees, and we can look, and it says 199.06. Now, from this exact same spot, so we don't have to, and we're going to now measure this angle, it's 200.85, and this one was 199.04. So that is the change in angle relative to the bird. The bird change in angle is 199.04 at 19 seconds and 200. A bit more. 200.85. All right, if we take a calculator, 200.85 minus 199.04 equals 1.81. So the amount the driver changed in those from 19 seconds to 25, so about 6 seconds, was maximum 1.8 degrees relative to the bird. So now we've come down to road level, just to simulate what's going on here. Remember this line over here, blue line, goes to the bird. And let's travel along. We've just traveled 18 meters, and this one goes to the bird. It looks like you've changed angles dramatically, but in fact we worked out that this angle over here is actually less than 2 degrees. So you're not going to be able to detect a change in the orientation of a bird less than 2 degrees, especially a bird which is not clear to begin with. So yes, it seems that you've traveled quite a huge distance and the angle of orientation has changed dramatically, but that's just an illusion. The fact is, this angle over here, if we zoom out, is actually a very small angle. It looks large from the perspective of the driver, but it's actually less than 2 degrees. So in short, Anthony Riley and Numbynumb declared that sound is a fraud based on their flawed analysis of the bird's orientation. I've just shown that you actually have changed only about 2 degrees, and that means that it's or 2 degrees is going to be impossible to detect the change in orientation on this bird, especially as this bird is not very clear to begin with. So when is Anthony Riley, and I mean I'm going to issue an apology to Soundly for the false accusation of fraud.